This video is going to show you how you can do the analyses for the Chapter 6 case. This is the whodunit case in SPSS. So what I've done is to bring up the data set, which you can get from Baboogle, where I've typed in the data. So what's in your course packet is exactly this, these numbers, but I've just entered them into SPSS. Now the thing to note about this data set is that it only has 12 rows. So we have one row for every combination of supervisor, domestic overseas, and then whether it's defective or non-defective. So there are 3 supervisors times 2 types of domestic times 2 types of defect. So 3 times 2 times 2 is 12, and that's why there are 12 rows. Now there's an additional variable, which is the count variable. This count variable indicates the number of orders in each of these rows. So this first row has a count of 3. What that means is that Wallace produced 3 orders that were domestic orders and defective. Wallace produced 293 orders that were non-defective and domestic. Okay, so this first row is to count 3 times because it represents 3 orders that he did. The second row has to count 293 times. Okay, so if we just analyze this straight away, we would get kind of silly results. Everything would have a defect. Everyone would have a defect rate of 50%, since there's a perfect balance in this data set. There's one defect, one non-defect, and so Wallace would have a defect rate of 50%, but that's not right, because really he had 293 non-defects with 3 defects. So the way we have to address this count variable is to weight cases. So to weight cases, you go up to data, weight cases, and then you want to say instead of not weighting cases, weight cases. We're going to do it by the count variable. So go hit OK. Now at this point, you'll notice that in the lower right-hand corner here of SPSS, weights are on. There's a little indicator telling us that weights are on. Now, the first question in the case asks us to study defect rates by supervisor. There's a number of ways that we can do this. Let's start out with a crosstab. So we're going to go up to Analyze, Descriptives, Crosstabs. Click that. And I will put supervisor in the row. We'll put defects in the column. The other thing we want to do is go into cells. So I'll move this up. Go hit cells. And I want to be able to study defect rates for each supervisor. So we're going to condition on supervisor. Notice supervisor is a row variable. Therefore, I want row percents. Go hit continue and hit OK. Now, if we look at the results, what you'll see is that 14% of Wallace's orders, this is within supervisor, so 14.3% of Wallace's orders are defective. Where did that number come from? Well, it's 258 divided by 1798. We could also say that 85.7% of Wallace's orders were non-defective. We can say that 7.8% of Jones's orders were defective. 92% of Jones's orders were not defective. So we can look at this crosstab and say that, well, Wallace has a higher overall defect rate than Jones. Another way to analyze this is to create a bar chart. So let me illustrate that. We're going to go up to Graph, Legacy, and then go up to Bar Chart. We're going to do a simple bar chart. And we will stick supervisor on the category axis. We're going to put the mean defect rate on the bars represent axis. So click on Other Statistic and copy defect in. Remember that the mean of a 0-1 variable is just the percentage of ones. So this is going to give us the percentage of defective orders. Go hit OK. What you'll see is that you get a bar chart that shows exactly what the crosstab showed. So Wallace has a 14% defect rate, Jones is at 7.8%. Now the next thing the case asks you to do is to break this out further by whether it's domestic or overseas. So let's see how we could do it both ways. Let's go into Analyze Descriptives Crosstabs again. And the way we can bring domestic overseas in is to copy it into this layer box. That's all there is to it. The layers will create separate crosstabs, you'll see here, for domestic, overseas, and then it'll give a third one which gives us exactly what we saw before. So we really didn't need to run the crosstab before, in that we have it here. Now what you'll see within this crosstab is a couple of things. First off, the overall defect rate across all supervisors is much higher for overseas orders than for domestic orders. So across all supervisors, 19% of all overseas orders are defective. Only about 4.7% of domestic orders are defective. So that confirms what Wallace was claiming in the case, that overseas orders are more difficult. Everybody has more trouble with overseas orders than domestic orders. Now let's look within overseas orders. So within overseas orders, Wallace has a higher defect. Wallace has a 17% defect rate for overseas orders. Jones is at about 40%. So Jones has the worst defect rate within overseas. Within domestic, well, Jones has a 5.2% defect rate, where Wallace only has a 1% defect rate. Now we could look at this with a bar graph, so completely equivalent bar graph, as follows. Let's go back to legacy dialog, and then we're going to go to bar graph. Keep it simple, so simple bar graph. And I'm going to copy domestic overseas into the panel by box. So panel by is just like layers. I'm going to get a separate bar graph for overseas and domestic. And so you'll see exactly the same thing. Everybody has a higher defect rate on overseas versus domestic, so overseas is harder. Point one. Okay, now point two is, well, within overseas, Jones is the worst supervisor. Within domestic, Jones is the worst supervisor. So how can this possibly be? Let's go run another crosstab. This time I'm going to get defect out of the column, and we're going to put domestic into the column variable. So we're going to run supervisor versus domestic / overseas. And so what you're going to see is that 16% of Wallace's orders are domestic. 83% of Wallace's orders are overseas. So Wallace does mostly overseas orders. Jones, on the other hand, does 92% domestic. So 92% of Jones's orders are domestic, only 7% are overseas. So when we compute an overall defect rate, what's happening is for Wallace, we're in essence averaging these two bars. But since most of Wallace's orders are overseas, this bar, which is much higher, gets a whole lot more weight, like 82% of the weight, versus this barely counts at all because he does very few domestic. That's why Wallace's overall defect rate appears to be much higher. Jones, on the other hand, this bar hardly counts at all because he only does a small percentage of overseas orders. 92% of his orders are domestic, so that bar counts 92% of the weight. And that's why the story flips. So this is called Simpsons Paradox. You can go to the course packet and click on the Wikipedia page for Simpsons Paradox and see a lot of other examples of this. So it's a very famous situation. And I just wanted to illustrate this in SPSS. The big point is beware the omitted variable. When you consider this domestic overseas omitted variable, the story flips.